Example 35.1. Determine the standard enthalpy change of formation of nitrogen monoxide. Bear in mind, use green highlight pen to highlight our target. This is important. If you haven't got your target, then you are not solving the problem, okay, properly. After that, refer to the target reaction. Write down, change the term into equation. Formations of nitrogen monoxide. Nitrogen monoxide should be written on the product side. Its elements are N2 and O2. Bear in mind, keep this coefficient 1, so half and half. This is our target. We need to solve. We need to work out this value. And then next, these two are the data given. This is the first step, N2, half N2 react with O2 to form NO2 with positive 34 kJ per mole. This is the second, 2NO2 to form 2NO2. Now, how to solve this problem? Again, I would like to show you two different methods. The first one, draw enthalpy change cycle or energy change cycle or energy change cycle. Do you remember what is the first step? The first step is our target. Write down this target reaction horizontally. Bear in mind, this is our target. We want to solve this number. Now let's start. Look at this first step. Half NO with 1 O2 to form NO2. Half N2, we have only half O2, it doesn't matter, you can add to form NO2. You need half O2 for this reaction. I label it as delta H1. Okay? Next, 2NO react with 1 O2 to form 2NO2. In our cycle, we need only 1 NO, but here there are 2 NO, so you need to do something. That is, divide this equation by 2 before you draw anything, okay? In dividing this equation by 2, do you remember what should be the delta H? The delta H should also be divided by 2, which is 56 kJ per mole. Okay? So, in this example, you need to change the coefficient. Divide the whole equation by 2. Bear in mind, you need to divide the enthalpy change by the same factor. After that, put them together. NO, that is the reactant, point it downwards. Add half O2 to form NO2 with number equal to negative 56. That is delta H1 with a number equal to positive 34. Now let's focus on this cycle. Take out 2 color highlight pens. Can you highlight them in different route? Again, you may consider this arrow belongs to clockwise arrow. This is also a clockwise arrow. That means these two belong to this these two reactions belong to the same root, then this is another root, only one step, anti-clockwise. Next, put them together. Delta HF plus 56 should be equal to positive 34. Therefore, is equal to 34 plus 56, which is equal to 90 with a positive sign, 90 kilojoule per mole. That's the answer. Again, please try by yourself. Now I would like to show you the second method by doing summation. Now again, first of all, you must bear in mind this is our target. Okay? In the target reaction, we have half N2. There is half N2. So simply copy down the first equation, half N2 O2 to form NO2 with a number 34. And then look at the equations again. We have NO, 1 NO on the product side. So what do you need to do? Follow the same argument. Divide the second equation by 2, and bear in mind the delta H should also be divided by the same factor, which is negative 56. Next, reverse the direction. That means NO and half O2 should be written on the right hand side. The product becomes the reactant. What should be the delta H? You should change it from negative 56 to positive 56. Now, in doing summation, you can see that there's one NO2 and there is another one. Half N2 on the reactant side, 1 O2, and there is half O2. So, half O2 on the reactant side, and then NO. Okay, now you can sum them up. Then you can work out the answer, which is 90. Bear in mind, write down the unit, kilojoule per mole. It's difficult. You must try, okay?